The universal set is defined as positive numbers less than 30. The set L is defined as positive multiples of 2 less than 30. The set M contains positive multiples of 3 less than 30, and the set N contains positive multiples of 5 less than 30. And here they want us to list the elements of L, and L contains positive multiples of 2 less than 30. And so let's list the elements of L, of set L. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and 28. These are the elements of set L. Next, they want us to list the elements of set M. Now, set M contains positive multiples of 3 less than 30. And so what are the multiples of 3 that are less than 30? What are the positive multiples of 3 less than 30? Well, we have 3, 6, 9, 12, 15, 18, 21, 24, and 27. So these are positive multiples of 3 less than 30. Next, they want us to list the elements of N, and the elements of N are positive multiples of 5 less than 30. And so we have set N, and set N contains positive multiples of 5 less than 30. So let's list them. We have 5, 10, 15, 20, and 25. So these are positive multiples of 5 less than 30. Next, we have to list the elements of L intersect N. We have to list the elements of L intersect N. So the set L intersect N would contain the elements that both L and N has, right? The elements that are in common in both sets. So we list the elements of L and we list the elements of N. Now, which elements are in common in both L and N? Well, 10 is common in both sets and 20 is common in both sets. So that means that the elements of L intersect N would be 10 and 20. So this would be the intersection of L and N. So L intersect N is equal to the set which contains the elements 10 and 20. Next, we have to list the elements of M complement intersect N. So in order for us to do this, what we have to do is we have to figure out what is M complement and then figure out what is N. And once we find those two sets, we're going to choose the elements that are common in both sets. And that would be the intersection of M complement and the set N. So what is M complement? Well, M complement is equal to all the elements in the universal set. So this is the elements in the universal set. And M complement is equal to all of the elements in the universal set except for the elements in M. So again, the M complement is equal to all of the elements in the universal set, except for the elements in M. So what is the universal set? Well, the universal set contains positive numbers less than 30. So we start from 1, we go 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to, we don't include 30, so it's positive numbers are less than 30. So we go all the way up to 29, all right? Okay, so now what is M? We have M. M is positive multiples of 3 less than 30. And so what we do here is we are going to eliminate all of the elements in M from the universal set, because M complement is all of the elements in the universal set except for the elements in M. So we eliminate all of the elements in M that are in the universal set. So we do that. So we eliminate the 3, the 6, the 9, 12, 15, 18, 21, 24, and 27. So we eliminate all that. So what do we have left? Whatever we have left is M complement. So we have 1, 2, 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, 19, 20, 22, 23, 25, 26, 28, and 29. So these are the elements of M complement. Now, what are the elements of set n? Well, set n is equal to positive multiples of 5 less than 30. So it's going to be 5, 10, 15, 20, and 25. And so what elements are common in M complement and set n? So let's find them. So 5 is common in both sets, 10 is common in both sets, and 20 is in both sets, and 25 is also in both sets. So that means that the intersection of M complement and set n is equal to 5, 10, 20, and 25. Next, we need to determine the number of elements in L union N. So we need to figure out what is the number of elements in L union N. But even before we figure out the number of elements in L union N, let's just figure out what are the elements of L union N. So we have set L and we have set N, and the union is going to be all of the elements in set N. I'm sorry, the union is going to be the union of L and N is going to be all of the elements in set L and all of the elements in set N combined, but no repeats. All right, so the union is going to be all of the elements in set L and all of the elements in set N with no repeats. So that means that the union would be 2, 4, 5, 6, 8, 10, 12, 14, 15, right? 16, 18, 20, right? 22, 24, 25, 26, and 27. So the union of L and N is this set, right? It contains all of the elements in L and all of the elements in N combined, but no repeats. And so, okay, so now how many elements are in the set? We can count. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are 17 elements in the, there are 17 elements in the union of L and N. So that means that the number of elements of L is supposed to be capital L. So let's put capital L. The number of elements of L union N is going to be equal to 17. So the answer here is 17. Next, it says, describe the set L intersect M in a similar manner as the descriptions given for the sets L, M, and N. So we have the set L and we have the set M, and we have to figure out what is the intersection of these two sets. Now the intersection is going to be all of the elements in L and M that are common or that are alike. And so what are the sets that are common? What are the numbers that are common? Well, 6 is common to both sets, 12 is in both sets, 18 is in both sets, and 24 is in both sets. So that means that the set L intersect M is going to be equal to 6, 12, 18, and 24. And so if we were to describe this set L intersect M in a similar manner as the descriptions given for sets L, M, and M, our description would be the following. Positive multiples of 6 less than 30. Because these are indeed positive multiples of 6 less than 30, and they follow a similar pattern of the set of the way in which the sets L, M, and N are described. And so that's the answer to this question.